Good Doctor here. I'm here to answer some more of your questions. Now, particular welcome today for Badger class, because this is the first time your primary school have asked a Good Doctor. So I've looked through your questions and they were very good ones, and I've picked the question I'm going to answer. That question is, how heavy is the sky? Now, if you look up into the sky, you can see the moon behind me there. You think, well, there's nothing there, there's just air and then nothing, but air actually has a mass.
I dreamed I was missing, you were so scared, but no one would listen, 'cause no one else cared. After my dreaming, I woke with this fear. What am I leaving?
Because we're in the air, we don't feel the mass that it has. What we need to do is create a situation where the air has gone from one place and then we can feel the rest of the air pushing down on that space. I'll show you that with a diagram. To show you what that's like with a real bottle, imagine the air is pushing down here, but the bottle isn't squashing. That's because air is inside and pushing back up. Quite clearly, you can push hard enough to squash the bottle. So why doesn't the atmosphere do that itself? Well, it will do if we remove the air from the inside. I'm going to empty the water out of this bottle, and I think you know what happens. Water will come out and then air will come in to replace it. If you have a look, you see the bubbles of air going back in. Now what I'm going to do is I'm going to put a tube on here which will stop the air going back into the bottle and have a look at how that affects the water coming out. Let's see what happens. All those units, don't worry about them, they're very complicated. Maybe remember 1 atmosphere. But what does it actually mean? Well, what it means is that the air is pushing down on the ground. To show you by how much, look at this piece of paper. If I put this piece of paper on the ground and put all my weight on it, that is the same as the amount of air directly above the paper is pushing down. Okay, so if I put my weight on that area of space, the pressure I'm pushing down is the same as the air pressure is pushing down on that space. To show you my pressure, I'm going to push down on this can, and you'll see how much pressure I can use to push down. Okay. This test is with a can, it's got nothing in it, it's an empty can. What I'm going to do is put a small amount of water in there, and then I'm going to heat the water, and steam is going to fill the can. That will push all the air out. I'm then going to get rid of the steam very quickly so that there is no air inside the can, but there is air outside. And we'll see what happens with the weight of the air pushing down on the can when there's no air inside to push back. Right, for this experiment I've got a piece of plastic tubing. I'm going to put a little bit of polythene at this end, and I'm going to suck the air out of this part. What that will mean is the whole of the tube has no air in it. Okay, I'm then going to put an object in this end, and when I let go, the air will rush in and push the object through the polythene at this end. I hope you enjoyed the video. There are 15 quadrillion tons of air in the atmosphere, but I've just shown you how just one little part of it above your head can push down really hard. Thank you very much for all your questions. I hope to see you again soon.